Hello students, we have already started elements of group 16, 17 and 18. Today we'll continue this. Reactivity of group 16 elements towards the hydrogen. Elements of group 16, this is known as oxygen family. They react with hydrogen to form their hydrides of the type H2E. Here E is equal to member of this group 16, that is oxygen, sulfur, selenium, tellurium and polonium, and they forms the hydride of the type H2O, H2S, H2SE, H2TE and H2PO. Means oxygen form hydride H2O, sulfur forms H2S, selenium forms H2Se and tellurium forms H2Te, while the polonium forms H2PO. This hydride of oxygen H2O, it is colorless, you know very well, that is water. It is colorless, odorless liquid. H2S, H2Se and H2Te, H2PO, these are also colorless, but they are having bad smell and they are also poisonous gases. All the hydrides, they have angular structure with sp3 hybridization of the central atom, that is oxygen. Hydrides of group 16 elements, they are weakly acidic, and acidic character of these hydrides increases from the first member oxygen to the last member H2E, H2Te. This is due to the decrease in bond dissociation energy of He, when means the bond between hydrogen and the respective element of this group, that is oxygen, sulfur, selenium, tellurium and polonium. This bond dissociation energy decides the acidic character of this uh, compound. All the hydrides of this group except H2O, they possess reducing property, and this reducing property increases in order. H2S is less uh, reducing, means it is having less reducing character than H2Se, and H2Se is having less reducing property as compared to the hydride of this tellurium, that is H2Te. Then we'll move to the next slide. Reactivity of group 17 elements towards the hydrogen. These elements of group 17 reacts with hydrogen to give hydrogen halides. Means we will see the example, that is when hydrogen, it reacts with halide, that is X2. When it reacts with this X2, it forms halide of the type 2HX. And here X is nothing but any halogen, that is fluorine, or it may be chlorine, bromine or iodine. Acidic strength of hydrogen halide, it increases in the group, or you can say it increases down the group. Means HF is less HF is a less acidic strength. HF is having less acidic strength as compared to HCl, and HCl is having less acidic character as compared to HBr, is having less acidic character as compared to HI. Means the strongest acid in this group or in this family is HI, and this acidic strength increases down the group from fluorine to iodine, and it is due to the decreasing bond dissociation enthalpy of HX bond. In the order, HF is having highest bond strength or bond enthalpy as compared to HCl, is having more strength than HBr, than HI. and this thermal stability of the hydrogen halide decreases in the same order. Means this HF is more thermally more stable as compared to HCl, and then HBr, then HI. Reactivity of the group 18 elements towards hydrogen. As we know that group 18 elements, these are the noble gas elements, or you can say these are the inert gas elements. These are chemically inert. Their shell, outermost shell is completely filled, so they are inert elements. They inert towards hydrogen due to their stable electronic configuration. They do not react with any of the element, or uh, they do not react with hydrogen. This is all about the reactivity of group 16, 17 and 18 elements towards hydrogen. Now we'll move to the next slide. Reactivity of group 16 elements towards oxygen. You know that group 16, it starts with oxygen, and all the elements of this group 16 forms oxide of two types. First one is EO2 and another is EO3. So the next member of this family is sulfur. It forms oxide SO2. Also it forms EO3 type of oxide, that is SO3. Means sulfur forms SO2 and SO3, both the type of oxides. Then selenium also forms both the types of oxide, that is SeO2 and SeO3. Tellurium also forms TeO3. And SO2 is a gas, then SeO2 is a solid. These are acidic and reacts with water to form acid. Means when SO2 reacts with water, it forms H2SO3, sulfonic acid. SeO2, when it reacts with water, it also forms acid, that is H2SeO3. Then SeO3, selenium trioxide, when it reacts with water, it also forms oxide of the type H2SeO4. TeO3, when reacts with water, it also forms oxide H6TeO6. Means this is the reactivity of group 16 element towards oxygen. Now we'll move to the next slide. Reactivity of group 17 elements towards oxygen. Group 17, it is nothing but the group of the halogens, that is fluorine, chlorine, bromine, iodine and acetylene. These elements, they also reacts with oxygen to form different oxides. First oxide of the fluorine is OF2. Then it also forms O2F2. Then OF2, it is thermally stable oxide of the fluorine. Chlorine also form different oxides like Cl2O, then ClO2, Cl2O6, Cl2O7. These are the different oxides formed by chlorine. Chlorine reacts with oxygen, means single atom of oxygen, to form Cl2O. When it reacts with two atoms of the oxygen, it forms ClO2. Then Cl2O6 and Cl2O7, these are also the different oxides of the chlorine. And all these oxides are highly reactive and they are oxidizing agents. Bromine, it forms oxides Br2O, BrO2, then BrO3, and they are less stable oxides and they are also powerful oxidizing agents. Iodine, it forms oxides like I2O4, I2O5, I2O7, and they are insoluble solids and they decompose on heating. Means all the oxides of the iodine, they are insoluble and solid, and also they get decomposed when they are heated. Group 18 elements are chemically inert and they do not directly react with oxygen. Then we'll move to the next slide, that is reactivity of group 16 elements towards halogens. These group 16 elements, they form three different types of the halides when they react with halogen, that is hexahalides, tetrahalides, dihalides. When they react with um, the element of the, that is halogen, to form hexahalide like SF6, means sulfur reacts with fluorine to form sulfur hexafluoride SF6. Selenium also reacts with fluorine to form hexahalide, and that is SeF6. Selenium hexafluoride SeF6. Tellurium also react with fluorine to form tellurium hexafluoride TeF6. All these hexahalides of group 16 elements are colorless, they are gases, and they shows hybridization of the type sp3d2. Octahedrals, they are having octahedral structure and their stability decreases from fluorides to iodides. Then group 16 elements also form tetrahalides, means 4 halogen atoms at the time reacts with group 16 element and form tetrahalide like SF4, means sulfur tetrafluoride. Sulfur reacts with 4 atoms of the fluorine to form SF4. Selenium also reacts with 4 atoms of the fluorine to form SeF4, selenium tetrafluoride. Tellurium forms TeF4 and tellurium also reacts with chlorine to form tellurium tetrachloride. All these tetrahalides of group 16 elements, they undergoes sp3 hybridization and their geometry is trigonal bipyramidal. These group 16 element, when they react with 2 halogen atoms at a time, they form dihalides, means 2 chlorine reacts with sulfur to form SCl2, sulfur dichloride SCl2. Selenium also react with 2 atoms of the chlorine or a single molecule of chlorine to form selenium dichloride. Tellurium forms TeCl2, tellurium dichloride, and they shows hybridization of the type sp3 and their geometry is tetrahedral with 2 equatorial positions occupied by this central atom, that is sulfur or selenium or tellurium. This is about the reactivity of group 16 element towards halogens. Now we'll move to the next slide. Reactivity of group 17 elements towards halogen. These group 17 elements, they react with halogen atom and forms different compound of the type of this following type. Halogen combines amongst themselves and they form the number of compounds. These are known as interhalogen compounds, means halogens combines among themselves and form the compound known as interhalogen compounds, and these are of these types: X, X dash, X, X dash 3 or X, X dash 5, X, X7 dash, like this. Sorry. Here X is the halogen atom which is larger in size and X dash is the halogen which is smaller in size. Group 18 elements, they also combine with halogen, and these group 18 elements, they are, although they are chemically inert, krypton, xenon reacts directly with the fluorine and it forms their respective fluoride. Xenon, when it combines with chlorine gas at 673 Kelvin temperature, it forms XeF2, which is in solid form, and temperature and pressure condition for this reaction is 673 degree Kelvin temperature and 1 atmospheric pressure. It forms XeF2. Sometimes it also forms XeF4, means xenon tetrafluoride, xenon hexafluoride. These are also the compounds formed by xenon, and they all are crystalline, colorless, and sublimates radially, means they get sublime at 298 Kelvin, means they get evaporated at 298 Kelvin temperature. Now we'll move to the next slide. Reactivity of these group 16-17 elements towards the metals. Group 16 elements, they react with different metals to form corresponding compounds. For example, when the first member of group 16, that is oxygen, reacts with the light metal like aluminium, it forms the compound Al2O3, means aluminium. 4 atoms of aluminium combines with oxygen to form Al2O3. It also reacts, means these group 16 elements, they also react with different members of the group 16, that is second member, that is sulfur. Copper, means copper, this is the metal. When it combines with group 16 member sulfur, it forms CuS, cupric sulfide. Then magnesium, it combines with selenium to form magnesium selenide, MgSe. Group 17 elements, they also react with different metals instantly and they form the respective halide. For example, sodium, when reacts with chlorine, it forms sodium chloride. Magnesium, when it reacts with bromine, it forms magnesium bromide. Ionic character of this compound decreases from fluorine to the iodine in this order, means this metal fluoride of this group 17 element is more ionic in character as compared to MCl, and MCl, metal chloride, is more ionic as compared to metal bromide, and metal bromide is more ionic as compared to metal iodide, means ionic character decreases from fluorine to iodine when it combines with the metal, that is the monovalent metal. And noble gases, as you know that all these are inert gases, they do not react directly with metals. Now we'll move to the next slide. Allotropy. Allotropy means the same substance when it is showing or it is having different physical form, such forms are known as allotropic forms. Oxygen, it is having two allotropes, means two different physical forms. That is one of the allotropic form of the oxygen is dioxygen O2 and another allotropic form is O3, that is ozone. Sulfur, it also shows different allotropic forms like rhombic sulfur, monoclinic sulfur. Selenium shows red and gray, means these two allotropic forms. Red, that is non-metallic selenium, and gray is the metallic selenium. Tellurium, that is the next member of this oxygen family or group 16. It shows crystalline and amorphous allotropic forms of this tellurium. Polonium, it is also showing different allotropes like alpha polonium, beta polonium, and both these forms are metallic in nature. This is all about the allotropic forms of group 16 members. Now we'll move to the Next slide, that is oxo acids of sulfur. Sulfur, it forms different oxo acid, and their structure and the formulas, they are shown in this slide, and they can be asked in your board exam. Write down, means question can be in this form. Uh, what are the oxy acids of sulfur? Write the structure and formula of any 4 oxo acids of sulfur, or any 2 oxo acids of sulfur, means depending on the nature of question or marks, you can write one or more structure and their formulas of the oxo acids of sulfur. The first oxo acid is sulfurous acid, that is H2SO3. This H2SO3 is having structure in this way. Sulfur is the central atom, and it is bonded, means it is having single sulfur oxygen double bond, and it is connected with the 2 OH bonds. Then in the next oxo acid, that is H2SO4, the central atom sulfur, it is bonded with the 2 oxygen atoms with double bond. See, this is one of the double bond, sulfur oxygen double bond, and this is another sulfur oxygen double bond. It is the central atom sulfur, it is bonded with 2 OH atoms, SOH. This is one of the SOH bond, and this is another SOH bond. Means this oxo acid, it is having at least one sulfur and oxygen double bond, and this one or two sulfur OH single bond. Then the next oxo acid is di, or it is also called as a pyrosulfuric acid, which is having molecular formula H2S2O7. See, in this, as there are 2 sulfur atoms, these are bonded with one of the bridge of, that is oxygen, sulfur, oxygen, sulfur. This is called as the pyro bond. Sulfur, oxygen, sulfur, this linkage is known as a pyro. So this name of this compound is pyrosulfuric acid. Pyrosulfuric acid means in this SOS type of linkage is there, compulsory. So while remembering structure, you have to remember that pyrosulfuric acid is containing at least one SOS bond, and sulfur atom is bonded with 2 oxygen atoms with 2 double bonds. See, this is one of the SO double bond, and this is another SO double bond. Sulfur is also linked with one OH bond, one OH atom. So S double bond O, S double bond O, S OH, and this structure, when it is repeated, it gives rise to pyrosulfuric acid. Means this is the mirror image. See, O is the central atom, and same structure is repeated on this side also. S double bond O, S double bond O, and SOH bond. This is the structure of di, or pyrosulfuric acid, having molecular formula H2S2O7. See, this is H2, means these are the 2 hydrogen atom, S2, 2 sulfur atom, and O7, 1, 2, 3, 4, 5, 6, and 7 oxygen atoms. Then the next oxo acid of the sulfur is peroxymonosulfuric acid. In this, sulfur means central atom sulfur, it is bonded with the 1 OH and 2 SO double bond, means S double bond O, S double bond O, and it is bonded with OH atom, but that bond is not direct, but it is through this through this oxygen. So it is known as peroxy, means in between sulfur and OH there is one oxygen atom. So this acid is known as peroxymonosulfuric acid. Hope you have understood these structures. Now we'll move to the next slide, that is peroxydisulfuric acid. We have just now we have seen peroxymonosulfuric acid, and when the same structure is repeated again, it gives rise to peroxydisulfuric acid having molecular formula H2S2O3, O8. See in this sulfur oxygen, this double bond SO double bond, SO double bond, this is, and S is bonded with one OH through one peroxy unit, that is oxygen, and this structure, same structure is again repeated. See again oxygen atom, SO double bond, SO double bond, and SOH bond. When means when you draw the line or mirror, when you keep mirror at this position, you get the same structure again. So this is known as peroxy disulfuric acid having molecular formula H2S2O8. See, there are two hydrogen, H2, S2, 2 sulfur, and 8 oxygen atoms in this molecule. And the last oxo acid of sulfur is